so we are going to finish up working with inequalities with our last step, solving multi-step inequalities. Because we are going to take a lot of what you already know and put it together in this lesson, we only have one vocabulary word. This one is not even new to you. It is the definition of an inequality, which you know is a statement that is formed by placing an inequality symbol between two expressions. So we are going to complete 4 examples, solving different types of multi-step inequalities and then graphing some of them. Okay, let's take a look at this first one. We have 8 plus c divided by 11 is less than or equal to a positive 10. This is a lot like when we were solving expressions. Remember, the only difference in the steps is that, well, really no difference. We're following the same steps. Our goal is to isolate the variable. The only difference is that we have inequality symbols now instead of equal signs. And what's happening here is that the c has 2 numbers with it. 2 things are keeping it from being alone. It is being divided by a positive 11, and it has a constant positive 8 with it. And just as we did with equations, we are going to negate the constant first. And since our constant is a positive 8, we will do that by applying a negative 8 on both sides of this inequality. So what we do now is we simplify, and these 2 zero each other out, and on the left we have one term, c divided by 11 is less than or equal to 2. Narrow down to a one-step inequality. The c is being divided by a positive 11. We have to undo that. The way to do that is to multiply both sides by a positive 11, because that's the inverse of being divided by a positive 11. And you know by now that when we are dividing a fraction by a whole number, we put that whole number over the denominator 1. Remember to multiply the 2 by a positive 11 as well. Now we have the 11s cross-canceling, and we are left with c being less than or equal to a positive 22. So we're halfway done. Our second part of our directions tell us to graph our solution. So we are going to draw a number line, and on it we will put a positive 22. Our next step, you remember, is we are going to put a circle over the number 22. We go back to our inequality and we see that our variable is less than or equal to. That means we have to color in that circle because the 22 is part of the solution. Since the solution set is less than 22, remember, less gets moved to the left. And so here we are. We have found our solution. C is less than or equal to a positive 22. And now we have graphed it. Let's take a look at example 2. Our directions are the same. We're going to solve the inequality and we're going to graph. Now this kind of expression that you see here on the right is very different looking from what you've been used to, because this is the first time that you are seeing a whole expression being divided by a number. What you're used to seeing is what we've seen just in example 1, where the variable by itself was in the numerator of a fraction. But that doesn't mean you won't know how to do this. Let's just take a look at what we have. We have 3 different terms right now keeping the variable company. And so one by one we're going to get rid of those terms. move them so that our x can be by itself. That has not changed at all. That's always our goal, get the x by itself. So let's take a look at what we have. We have the x being multiplied by -2. We have that term having a positive 6 with it, and that whole piece is being divided by 4. So what we're going to do is clear the fraction. What I mean by that is we are going to do the inverse of being divided by a positive 4, and we are going to multiply both sides by a positive 4 to do that. I'll show you how to do that. This side is easy. We have a -3 times a positive 4. We remember that it's less than. Now what we're going to do is rewrite this entire expression the way that it is. -2x plus 6 divided by 4. And we are going to, just as we did over here, multiply it by 4. And because this is a fraction, we are going to put that 4 over 1. And now we will simplify. A -3 times a positive 4 is a -12, is less than. These 4's cancel each other out, and so we're left with the expression -2x plus 6. Now that we've gotten rid of one of the numbers, we'll get rid of the constant. Our constant is a positive 6, which means we'll need to put a -6 on both sides of the inequality. So we have -12 minus 6 is less than a -2x. There's our positive 6, and here's our -6. We're combining a -12 and a -6, and that gives us a -18 is less than. We're left with just a -2x because the net positive 6 and the -6 together make a 0. Now that we have the x down to just being multiplied by a -2, we will do the inverse of that, and we are going to divide both sides by a -2. And when we do that, we end up with a positive 9 is less than x. However, because you see we made the coefficient of 1. If you remember from the last lesson, what we learned was when you have to multiply or divide the variable term by a negative number in order to isolate that variable, we have to reverse the inequality symbol. So instead of being 9 is less than x, we have 9 is greater than x. I'll repeat that. From the last lesson we learned. See over here we have the x being multiplied by a -2. The rule is that when you have to divide by a negative number in order to get the x isolated, you have to take your inequality symbol and flip it. You have to reverse it. And so now we are going to graph our solution. So we start off by making our number line, and we have a positive 9. Now, we are going to keep an open circle over our positive 9, because if you see, the inequality symbol does not have the or equal to bar underneath it. That means the 9 is not part of the solution. Now, how do we graph it? In which direction do we go? Our rule of thumb is that we read the inequality from the point of view of the variable. Here the x is on the right side, so we will be reading this inequality backwards. X is less than 9. If x is less than 9, that means our arrow goes to the left. All the numbers here below 9, less than 9, are in the solution set. Let's look at our third example. Now again, I know your first reaction is that these might look a little intimidating, especially the example we just did with the whole expression in a fraction. But just keep reminding yourself that you have the skills that you need. We've been doing this with So with equations and with single-step inequalities, we're just taking more complicated inequalities, but solving them in the same way, one step at a time. So here we see a set of parentheses, and you know, order of operations dictates we take care of that first. And when we look, by now you know, that probably means there will be the distributive property, and that is true. So the first thing we have to do is use our distributive property principle. We are going to take our positive 6 and multiply the positive 5, which gives us positive 30. Then we have our 6 multiplied by the negative 2x, which is a negative 12x, is less than 5x plus 13. So this is like, see, we have the variable on both sides, and we have a constant on both sides. And if you remember when we were learning how to solve multi-step equations that had variables on both sides, what I wanted to do, or what I did, was I determined before I went through and solved it, which side I wanted to be my x side and which side I wanted to be my constant side, because that helped me to be more organized. So I'm going to call this my x side and this my constant side. Oops. You know, just to make this a little clearer, I'm going to erase this, because by now you already have that copied. And this is our constant side. So now what I do is I will go over here to the left. I'll recognize that this is my x side, and so I'll ask myself, which of these two terms does not belong here on my variable side? And then the answer to that is my constant. The 30 doesn't belong there. So the way to get rid of a positive 30 is to put a negative 30, and we have to put that on both sides. So we write down our original expression, and then add on a negative 30. Same on this side, we will write our original expression, and then our negative 30. Now we simplify. Our positive 30 and our negative 30 cancel each other out, and we're left with a negative 12x is less than, we'll do some simplifying here. We have a 5x, and we have to combine our like terms. Our positive 13 and our negative 30 make a negative 17. Now let's take a look over here. I remind myself that this is the constant side, and I look at my two terms. I have a 5x and I have a negative 17, and then I ask myself which of these terms does not belong in my constant column, and it's the 5x. So what we're going to do is put a negative 5x on both sides so that we can get rid of it from our constant side. So we have negative 12x and now a negative 5x. We keep that less than 5x minus 17 minus 5x. We'll combine our like terms. We have a negative 12x and a negative 5x, which make a negative 17x. Here, we canceled out our variable term, and we're left with just a negative 17. Now we need to isolate the x by dividing both sides by a negative 17, because that's the opposite of being multiplied by a negative 17. Our x has a coefficient of 1, and we have that x, now it says is less than, but we're going to make that is greater than 1. Do you remember why? Because we had to divide by a negative number in order to get the x by itself. So x is greater than 1 is our solution. and we have to graph it. So I'm going to, now that you have this copied, clean this up a little bit. We'll make our number line. Oops. Put our positive 1 here. Since it's greater than and not greater than or equal to, we'll keep that circle opened. If x is greater than 1, it means our solution is to the right of our positive 1. Okay, we have one more example and then we'll be done. Okay, look at this lengthy word problem. Make sure you copy all of it and I'll read it to you. A ski resort charges $45 for an all-day lift pass and $40 per day to rent skis. You can also purchase skis for $360. How many times must you go skiing for the cost of buying your skis to be less than renting them? I don't know about you, but when I first read this problem, I thought, boy, oh boy, does this sound confusing. There's a lot of information, there are a lot of numbers, big numbers, small numbers. How do we do this? How do we answer this question? I don't even know if I know what they're asking me. And that's normal. So remember what I do in class. I take out the information that we know. We try to cut through all the words, all the words that make the story interesting, but at the end of the day, we really don't need to solve the problem that they're asking us. So what do we know? We know that when you go to the ski resort, if you want to ski there, you'll pay $45 to have an all-day pass. We know that if you don't have your own skis, you can rent them there for $40 per day. And we also know that if you wanted, if you were somebody who went skiing often enough, you could purchase your own set of skis for $360. And now I took our very long, complicated question and I boiled it down to this. What we're being asked is, how many times do we have to ski for buying our skis to be, the cost of buying our skis to be less than the cost of renting? Because what you want to see is it worth it for you to spend almost $400 on a pair of skis if you really only go skiing a couple times a year? So now what we're going to do is we are going to take this information, plug it into this verbal model of an inequality, and then solve. How are we going to do that? Well, buying the skis. What's involved with buying your skis? Well, we know the cost of the skis is $360 plus $45 per day for the pass. So we'll call that 45D. And that must be less than the cost of renting. Now, renting will be $40 per day for the skis and $45 a day for the pass. Here's our inequality. 360, which is a constant because it's a one-time purchase for your skis, plus the all-day pass for $45 a day. And we want for that to be less than the cost of renting your skis every day and the cost of your pass. And what we can do is, I hope that what you've seen is there are like terms on this side, so we can simplify that. And we have this side stays the same for right now, 360 plus 45D. And we're going to combine these terms to be 85D, because if you were going to rent everything, you would spend $85 a day. Now, we have a constant and a variable here, and on this side, we only have a variable. So for me, it's a no-brainer, we're going to make this our variable side. So from here, this is our variable side, this is our constant side. We have to ask ourselves, which of these terms does not belong here on our constant side? And that is the 45D. So what we're going to do now, as you probably already know, is we are going to put a negative 45D on both sides so that we can get our constant by itself. And what we've done is we have our 360 by itself, and we have one term of 40D. And we know that we have to divide both sides now by the coefficient 40. And we get that 9 is less than D. So in other words, if you were going to ski only about 9 times a year or less, then it would be more cost effective for you to rent your skis. But if you were somebody who was going to go skiing more than 9 times, say 10 times a year or more, then it would be more cost effective for you to purchase your skis, because then you would be saving money after that. So here we have a real-life application, a real-life situation where you could use inequalities to see which would be your better option. And this concludes our lessons on inequalities. In our next lesson, we'll start something brand new.